The purpose of this lesson is to learn the difference between MyISAM and NODB, how to create and use database tables, how to alter database tables, how to drop or delete database tables, and how to repair a database table. Behind the scenes for a DBMS, there's this thing called the storage engine. It is the underlying component for the DBMS to be able to create, read, update, and delete data from a database. It is what is used to get data from the files that are on the hard drive out to a usable format for us as users. Now, every storage engine stores data in different file formats. And we talked about before that the DBMS is actually responsible for locking the files. It's actually the storage engine that does that. Some of them will allow for files to be fragmented, while others require the files to be in a consecutive or partition file. What that means is if I have a file that is not allowed to be fragmented, it has to be in one large contiguous space on the drive. And if I don't have enough room on the drive, then my file cannot be written and I won't be able to modify or update my database. The storage engine is also responsible for indexing if that is supported. Now, we will talk about indexing more in future lessons, but not every system allows the indexes. The first one that we'll discuss is MyISAM. This was actually designed for speed. It does not allow referential integrity or transactions. In a prior lesson, we talked about, we had customers and orders, and we talked about that it's possible for somebody to try to add a customer to an order, and the system will check to make sure that that customer exists before they let them actually create that record. MyISAM will not perform that function, which means that the developer would have to prevent that from occurring. One of the things that MyISAM does to protect the records is when somebody is performing an update on one record, it will actually place a lock on the entire database table. This functions kind of like Microsoft Access. So that means that if I'm trying to update somebody's telephone number during the period when I'm trying to update their telephone number, nobody else can do any lookups. They can't even do a select statement to see information about another customer. During the update process, there are no constraints or mechanisms to allow for a rollback, which means once you commit something to the database, it is committed. There is no way to get it back to the way that it was before. MyISAM was the default storage engine for MySQL prior to version 5.5, and it is ideal for tables that are used mostly for select statements. So tables where I want to get information out of them, but not necessarily where I need to update, insert, or delete items from it. There's also called the archive storage engine. This stores a large amount of data, but there are no indexes. It uses relatively little system resources, but is limited in its capabilities. It only allows for insert and select commands. It does not allow deletes, replaces, or updates, which makes it ideal for archiving data into a database that will not change once it's created. NODB is transaction-safe storage engine that supports foreign keys, commits, rollback, and crash recovery capabilities. It was created by a Finnish company called Innovase Oy, which has been acquired by Oracle. So since version 5.5, it has been the default storage engine used by MySQL. It allows for row-level locking, which means if I am in a record and I am performing an update, it only locks that row, and other users can perform queries on the other records that are in that database table, even though I'm updating one particular record. That one record would be locked, the other ones are not. It is designed for high volumes of data and provides the ability to use indexes, which once again we'll talk about those later. It is ideal for tables where integrity is important. It allows us to do things like rollback, and it allows for relational integrity capabilities. It is more fault tolerant, but requires more time and processing power than MyISAM. There is a configuration file that is actually used to make the change for what type of storage engine you want to use. In Windows, it's located under the program data /MySQL /MySQL server, and then whatever version it is. And the file name is actually my.ini. On Linux or on the Mac, it's located under /etc/my.cnf, or it might be under etc/MySQL. And to make the change, all you have to do is locate the line that says default storage engine equals NODB and change it to the storage engine that you want to use. Now, we are able to check tables. So let's say I have a table that I believe is corrupted. I can run a query on it that will check the table. And what this will do is it will verify the contents of the table to make sure that everything was written correctly, that the constraints were met, and it makes sure that the data that's in the table is actually written to the files properly. Now this works with MyICM, Archive, and NODB, and to actually perform this query, you just simply have to type check table and then whatever the name of the table is, and it will check it. Now in the older versions, so in MyICM, Archive, and even for CSV, which is a comma separated value file, it is possible to repair those database tables. So if I have a table and I run check on it, and check says that the file is corrupted, you can run a command which is just simply to repair the table. It's similar to the old recover command. The only thing is this is not supported by NODB. So if I use the NODB storage engine, it is necessary for me to create a dump file and reload it, which we will actually cover that in a future lesson. So once I write information to a table, I create the tables and I create the definition for all of the column names. But once the columns are there, I need to be able to modify those. So I can add columns, I can drop columns, I can modify columns, and I can also rename columns as needed. And what this is called is an alter table, which would look like this. They all start the same, so alter table and then whatever the name of the table is that I want to alter. And if I want to add a column, I say add whatever the column name is and the data type that it's supposed to be. If I want to drop it, I can drop it, which means to delete one of the columns. Be real careful when you delete a column though, because sometimes when you delete things, you break queries that are using those columns. So we want to try not to make changes to a database once we've actually put it out there. So if I have a program that's interfacing with it, and I drop a column and that program expects the column to be there, I'm going to break that other program. So like I said, we can add, drop, and modify columns, and then we can also rename them. Now if you need to rename a column, there is an SQL standard which is just simply rename column, and then you tell it the old name and rename it to a new name. In MySQL, we have to use the change command, and we just simply change whatever the old name was to the new name, and then we change its data type. I want to show you how this works. In a prior lesson, I used a command to create a database just for you to see it show up on the left side under schemas. I'm going to use that same command. So I want to create a database called test, and I am going to use my keyboard shortcut, which is Control-Enter, to issue that command. It shows at the bottom that it was successful. One row was affected. Now the one row that was affected was actually in one of the MySQL database tables to keep track of all of our other databases and tables. That's an item called metadata. It's just data about the other data. All right, so I create this database called test, and now I want to use it. Now it doesn't show up over here, so I'm going to refresh, and there's my database. If I look at the tables, I don't have any right now. So what I want to do is I want to use this one. Now I have two options. One is I can type the command that says use test, and that would tell it to use test database over here, which means that anything else that I do would be applied towards that database. Or I can just simply double click on it. And when I double click on it, it is now bolded. That means that is the one that is being used right now. So I want to create a database table. To create the table, I'm just simply going to type the command create, and I'm creating a table, and I will call it test table. Now, I can't just create a table, I have to put things into it. So what I'm going to do is I'm going to open up the parentheses here, and inside of here I'm going to list all of my columns. Okay, so what I want to do is the first thing is I want to have each record for it to have an ID. And then the ID is the name of the column. I have to tell it a data type. Now our data types are going to be things like integers, and I want an integer that's up to 4 characters in length. We also have characters, which if I do a char value, I have to specify an exact number of characters that will be typed in. We have varchar, which is variable length text string, so I could have anywhere up to a certain number of letters or alphanumeric characters. So in this case, I want my ID to be a 4-digit identification number, and I need this to be not null because I'm going to make this my primary key. All right, so then on the next line here, and remember MySQL ignores white space, so I can put each column on a separate line. I want to keep track of people's names. So first name, which is a data type of varchar, and I want it to be up to 50 characters in length. And once again, I'm not going to allow it to be null. And I want to keep track of their last name. And once again, it's going to be a varchar of up to 50 characters in length and not null because I want to force everybody to put this information in. And I'm going to put in their telephone number. And a telephone number is actually going to be a varchar because it has the hyphens in it. Now we can make it an integer and format it in whatever program actually interfaces with this to get the data out of it. But for this example, we're going to make it a varchar. And our telephone numbers are 10 digits in length, but I need to account for the 2 hyphens, so I'm actually going to make it up to 12 characters in length. But not everybody has a telephone, so I'm not going to specify that it can't be null. And what this means is that if somebody doesn't enter a value for it, it will just simply make it a null value. And the same thing with email. I want their email address to be a varchar of up to 50 characters in length. And once again, they may or may not have an email address, so I don't want to list that. However, I do want to keep track of their zip code. And their zip code is going to be a varchar. And once again, we have our 5-4. So if I use that format, then it needs to be up to 10 characters in length. And I don't want this to be null, so I'm going to specify that it's not null. My last thing that I want to put in here is I have to specify what the primary key is. So I'm going to list primary key, and in parentheses I will put the column that is going to be our primary key, which is ID. I do not put a comma after this last one because I don't need it and it would throw an error if I include it. I'm going to execute this. It says it was successful, and if I refresh over here, I will now see that I have a table, and I have test table, and then I do have columns that are in here. So if I look at this, I can actually look at the layout of it, and I will see that my ID column is a primary key, and then our other columns are listed with their data types. So that's all there is to creating a table. I want to drop this table. I no longer need it. I can drop a table, and it's called test table. Drop it. Now that table's gone. I can do the same thing with an entire database. So I can drop a database, and in this case I want to drop test, and now that entire database is gone. In a prior lesson, we were using the classic models database, and if I double click on it, it's now our database table that's being used. We had a table that was called customers, and it's the one that we were using in the last lesson. So I want to select everything from the customers table, and these are all of our customers. And if you notice, I have customer number, customer name, and then contact last name, contact first name. Well, in the last lesson, I kept mistyping this as customer last name and customer first name, so I noticed that I do it frequently, and I want to change the name of those 2 columns. So what I can do is I can alter this table, and I'm altering the table called customers. And what do I want to do? Well, I want to modify this table in such a way that I can change the name of it. Now, like I said, in the actual SQL statement, there is a rename command. In MySQL, it's called change. So I want to change the contact first name, and I want to call it customer first name. Now, when I do this, I still have to specify what its data type is. So it's going to be a varchar of 50 characters in length. So up to 50 characters. Now, what this will do is it will rename that column for me. So now if I were to do a query to select everything from customers, you will now see that I have a contact last name and a customer first name. So I'm going to do the same thing with the last name. And we're going to change it so that instead of being called contact last name, we'll call it customer last name. And that way I can quit mistyping it when I use it. Now, I did just rename it as customer number, customer name, customer last name, customer first name. Now, here's the problem though. If I had a program that was interfacing with this, I very likely broke my program. So I really don't want to make changes to a database if I can help it. The capability is there, but we don't necessarily need to use it because we end up breaking other things. All right, so I can do some other things too, like I want to add a column. So at the very end, I want to make a new column. So I'm going to alter table, and these will all start out the same. So alter table customers, and what do I want to do to it? I want to add a column called my new column. And we're going to make it varchar of up to 50 characters in length. Run this. Says it was successful. Come over here and rerun our select statement. And if I come across, you'll see that we now have a new column. Now notice when I created the new column, when we talked about our normal forms, first normal form says that every record has to have the same number of attributes. So it automatically puts a null for all of the columns where we didn't put any data. Every one of them now has a null value there. All right, so I don't necessarily need this column anymore. I can go ahead and drop it. So instead of adding the column, I can drop it. And I don't specify its data type, I just simply specify the name. So I alter the table called customers. We drop that particular column called my new column. Run it. And now when I refresh my select statement, that column is gone. The last thing that I want to play with is I have the ability to change data types. Now, right now, I want to know what all of these data types are. So I can use a command that we discussed last time called describe. And what do I want to describe? I want to describe customers. And when I describe customers, I can scroll down and I will see that our sales rep employee number is an integer of up to 11 characters in length. And let's say we've outgrown 11 characters, we need to make longer employee ID numbers. We would just simply need to issue a command to change that. So I'm going to alter my table. So alter table customers. We are going to modify sales rep employee number, and we're going to make it an integer of 20 characters in length. Now this will not necessarily delete data because we're just simply making it a longer possible integer, but what it will do is it will cause the other records that are already there to use up more memory space because they will have to allocate for that extra space. So when I run this, it says it was successful. Now notice the integer is underlined. This happens every once in a while. You can safely ignore that. But if I describe this table now, and I scroll down, then I will see that my sales rep employee numbers are now integers of up to 20 characters in length. I talked about being able to check a table. If you believe that one of your tables is corrupted, you can run a utility that will check it. There's a command, it's called check, and I want to check a table, and the table name is customers. Run it. And what it will do is it will tell me that classic models dot customers, it ran a check operation, its status is okay. So what this does is it lets me check the table to make sure that everything is okay. The only thing is that it will not allow me to repair it because this is actually an NODB storage engine for this particular database. Remember I said that is the default for MySQL. So if I try to repair it, I will actually get an error message. So what I would have to do, if this database table really is corrupted, I would have to export the data into a dump file and then re-import it. And we will talk about that in a future lesson. One thing I want to point out, because we'll start using this in the next lesson, is if you notice down here where the table name is, it's classic models.customers. This is normal. This is actually what's called a fully qualified table name. And the way that it works is you always start off with the name of the database, dot, and then customers. So what I can do if I want is I could actually perform a select statement where I could select everything, and instead of saying from customers, I could say from classic models.customers. And what this will do is I am fully qualifying it. So let's say I'm not actually using this database. If this one weren't bold right now, this would tell it, it doesn't matter what database I'm using, I want you to look in this particular database and find out what information is in there. So that's called a fully qualified table name. In this lesson, you learn the difference between MyISAM and NODB, how to create and use database tables, how to alter database tables, how to drop or delete a database table, and how to repair a database table.